Hello everyone. Today we are going to learn how to solve stoichiometric problems. Now, stoichiometric problems can present themselves in three formats. That can be mass and mass relationship, mass volume relationship, and volume volume relationship. Mass mass relationship meaning they'll give you reactant in kg, gram, and ask you to find the product mass in the same quantity. Mass volume would be reactant would be given in gram or kg. They might ask you to find the volume of the product expected in liter, milliliter, centimeter cube. And in volume, both the quantities, that is the reactant as well as product, would be given in volume ratios. Let's try to solve the first type, that is mass-mass relationship, for which I have picked up a question over here. Now, many students find stoichiometric problems to be a bit difficult because majority-wise, stoichiometric problems do not come with an equation handy. So you need to form an equation of your own and then only you can proceed with the question. Now let's see over here, they have given us carbon dioxide and water formed on complete combustion of methane gas. This formed word is actually pretty important. Formed here indicates that water and your carbon dioxide happen to be the products because products are formed, right? Products are formed. And who happens to be the reactant? Your methane gas. So when you read the question, calculate the mass, meaning the first problem, mass-mass relationship of products formed on the combustion of the reactant. So let's try to find it. Our methane gas is what? It is CH4. Okay, and we are getting what on combustion? We are getting CO2, that is carbon dioxide, and water. We can see we have carbon on the reactant side and product side, hydrogen on the reactant side and product side. Only thing missing over here is oxygen. So we need to add oxygen by ourselves, okay, on our own. Now let's see one carbon, yes. 4 hydrogens, 2 hydrogens. So you put a coefficient. Okay, now let's see, we have 2 oxygens, 2 plus 2, 4 oxygens on the product side. So we are going to balance it. Take a minute to understand whether it's balanced or not. Once we do the equation and we have completed the balancing, we need to find molecular weight. Molecular weight of each of the reactant and product. This happens to be step number 2. Step number 1, write down the equation, balance it out. Step number 2, find the molecular weight. So we have 1 carbon plus 4 hydrogens. How do we calculate 1 carbon? Carbon's atomic mass is given as 12. 4 hydrogens, atomic mass as 1. 12 plus 4, you get your value to be 16 grams. Okay, so CH4 has a molecular weight of 16 grams. Let's see oxygen, 2 2s are 4. We need to calculate 4 oxygens, right? We know 4 into 16, that comes around 64 grams. Okay, CO2, we have 1 carbon plus 2 oxygens. That becomes 1 12 plus 2 times 16. Okay, so 12 plus 32, which equals to 44 grams. And finally, we have 2 into 2, 4 hydrogens plus 2 into 1, 2 oxygens. So this is 4 ones are plus 2 times oxygen, that is 16. So this is 4 plus 32. What have we calculated over here? We have calculated a basic idea of the equation. Meaning when 16 grams of methane react with 64 grams of O2, we are bound to get 44 grams of CO2 and 36 grams of H2O, depending on the molecular weight. Okay. That happens to be the step number 2. Let's see what happens next. We have our CH4. We have our 2 times oxygen. We are reacting them. What are we getting? CO2 plus 2 times H2. We'll first mention out the molecular weight. Molecular weight of CH4 is 16 grams. O2 is 60, let's just check, 64 grams. CO2 is 44 grams and H2O is 36 grams. Correct? Yes. Now let's see what is given and what we need to find out. Okay, given is they have given us how many grams of methane? 24 grams of methane. So they have supplied us with 24 grams of methane. They have not talked about oxygen at all, but they have asked us to find how much CO2 would be generated and how much H2O would be generated. So let's try to tackle down these two equations one at a time. Okay, so from CH4, they are asking us how much CO2 has been generated. And again from CH4, they are asking us how many H2O is generated, how much H2O is generated. For this, first we'll write down the molecular weight that we counted, 16, and CO2 would be 44. Again over here, 16 and H2O would be 36. They have given us that CH4 is 24 gram. We need to find CO2. They have given us CH4 is 24 grams. We need to find H2. So simple procedure, we just need to cross multiply this. Only by cross multiplying, you would be able to get your desired product weight. Okay, so cross multiplication gives us X is equals to 44 into 24 upon 16. Y is equals to 36 into 24 upon 16. So when you calculate, you will understand that almost 66 grams of CO2 has been generated from 24 grams of methane and 54 grams of H2O has been generated from 24 grams of methane. So stoichiometric problems require a pattern of solving, which makes it easy. First step would be writing down the equation and balancing it out. Second step would be finding the molecular weight of each product and reactant. Third step would be analyzing what is given and what to find out. And the next step or the last step would be cross multiplying to get the desired product's weight. This is how we solve stoichiometric problem. By here, if suppose even 10% of your knowledge is clear of how to solve, let's try another question and you would be able to fill in the gaps. Okay. The next question says, we have how much CaO, calcium oxide, would be produced. Would be produced meaning calcium oxide would be a product by decomposition of CaCO3. So assign CaCO will be produced, meaning calcium oxide is the product. By decomposition, by reaction of CaCO3, meaning CaCO3 is the reactant. Okay, the question itself will give you what needs to be done. So we have CaCO3, there is decomposition over here, and we are getting calcium oxide. Let's try to balance it out. We have calcium. Yes, calcium is there. One oxygen, one oxygen. Remainder, we have CO2, which we need to assign by ourselves. Let's take a minute to see whether the reaction is balanced or not. One calcium in the reactant, one calcium in the product side. One carbon in the reactant side, one carbon in the product side. And 3 oxygens on the reactant side, 3 oxygens on the product side. So step 1 is done. We have formulated an equation. We have balanced it out. Step 2 is finding the molecular weight. How many calciums? 1 calcium. Calcium's atomic mass has been given, it is 40. How many carbons? 1 carbon, so 12. How many oxygens? 3 oxygens, so 3, 16. Let's see. So this becomes 40 plus 12 plus 48. 88 plus 12, it becomes 100 grams. Okay. So the molecular weight of calcium carbonate is 100 grams. Let's see calcium oxide. 1 time 40 plus 1 time 16. This makes it 56 grams. Over here, carbon is 12 plus 2 times oxygen. So this becomes 12 plus 32. That is 44 grams. Okay. We have understood that we have got our reaction in control. We have balanced it. We have completed step number 2 of finding the molecular weight. Let's go to the next step. What happens to be in the next step? Next step, we are first going to write down whatever we have found. So, my bad, CaCO3. We have it decomposing. We have calcium oxide. We have CO2. This is 100 grams. Molecular weight. Okay, this is molecular weight, 100 grams. This is 54. No, this is 56 gram, right? Calcium oxide is 56 grams. And CO2 is 44 grams. Yes. Now what is next? Next is what is given. We are going to analyze what is given. They have given us 5 gram of CaCO3, 5 gram of CaCO3, and they are asking us to find the amount of calcium oxide. They have spoken nothing about CO2, so please do not worry about what to do with CO2. Forget CO2. Okay. So what are they saying? That CaCO3 is generating calcium oxide. First write the molecular weight, 100 gram, 56 gram. Then write the given weight, 5 gram and x gram. Simply cross multiply. Okay, so x would equal to 56 into 5 upon 100. Take a minute to solve this and get the value of x. Your value of x will indicate the amount of calcium oxide being produced. So 56 into 5 is approximately 280. 280 divided by 100. Your answer should be approximately 2.8 gram calcium oxide. They have asked only about calculation of the amount of calcium oxide in the question. You stick to it. No need to find out how much CO2 would be produced. For practice, definitely you can find out how much CO2 can be produced from 5 gram of CaCO3. But or otherwise in examination, nobody expects you to find out the product weight of the products that are not even asked in the question. So for practice purpose, you can try as much as you can. Exam point of view, stick to the question and save your time. If you have understood even a good chunk of it, try to solve this equation. Here I have mentioned out an unbalanced reaction. So first step is you're going to balance the reaction which is given. Second step would be finding the molecular weight. Once you find the molecular weight of each reactant and each product, next you are going to understand what is given and what you need to find. Okay. And fourth step would be cross multiplying in order to get the amount of the required compound. Okay. Using these simple 4 steps, you can solve any stoichiometric problem that can come into your picture. If you have understood this, please try out this equation, and you can even try out more from the internet. Once you understand the basic procedure of forming and getting through the stoichiometric problem, it becomes a piece of cake. 4 steps and you're done with it. Signing off for today. Bye.